Hey everyone, hope you're having a great day. Myself Mukul Bisht and I, along with my teammates Yash Tamgadgi and Sonalika Arneja, have prepared this case study on blood bank management system. So let's take a look at it. So firstly, our case study, like everyone is familiar with blood banks. So what they do is they have an extensive network of blood donors and recipients, and they make sure that the needies get that in time. So obviously, to reduce the labor and time invested in maintaining the inventory or keeping tracks of the blood coming in, and the same thing be donated to whoever needs it, there is definitely a need of management. That is the database management we're talking about, and we have tried to counter the same problem keeping some assumptions in mind. So we could firstly take a glance at what the database represents. So we have separate tables for the donors and the recipients of the blood, along with a lot of information like age, gender, and much more. Other than that, we have a manager who manages the bank, and he has a name and an ID associated. And other than that, we could take a look at the date of registrations for the donor as well as the recipient. Other than that is the unique ID for each and every batch of blood that is collected in the blood bank. So this could be a very well way of querying or getting information on the same batches or when the time needs us to. And lastly, we can take a look at the assumptions that we have made, which are basically that for every region which has a PIN code, we have a single blood bank in that area. Moreover, a donor can only donate the blood once a month. And lastly, that every donated batch that we collect is analyzed for any diseases or allergies as such. So that's pretty much it. And next we can take a look at ER and EER. So thank you.
Good morning, everyone. Today I'm here to explain ER and EER diagrams. An ER diagram is used to show the relationships between the entities. An ER diagram uses 6 standard symbols. An entity may be an object with either a physical existence or a conceptual existence, such as a person, student, car, house, a company, job, etc. Let us take an example and say that we have an entity called student. Then this entity would definitely have some characteristics such as name, ID, and let's say class. All these characteristics that define an entity are called attributes. The relationships are the associations between entities. Weak entities depend on another parent entity because they do not have a primary key. Multivalued attributes are the attributes that can have more than one value, such as contact number, because a person can have more than one contact number. Weak relationships are the connections between a weak entity and its parent. All these ER diagram symbols can be represented as follows. Then the next topic we have is cardinality. The number of times an entity participates in a relationship is known as cardinality. When each entity takes part only once in the relationship, the cardinality is 1 to 1. For example, a male can only be married to one female and a female can only be married to one male. So this is a 1 to 1 relationship. The next we have is many to one relationship. Over here we see that one student can only be enrolled in one class, but one class can have many students. So it is a many to one relationship. The next we have is many to many relationship, where we see one student is enrolled in many courses, and similarly one course can hold many students. So it is a many to many relationship. The first step that we take while drawing our ER diagram is to identify the entities. So through our case study, we were able to identify 8 entities, which are as follows. The next thing we do is try to construct relations between these entities. So over here we can say that the donor donates blood. This can be a relationship between two entities, which are donor and blood. So similarly, we were able to find quite a few relations, which are as follows. The donor donates blood, the patient receives blood, manager manages the blood bank, clinical analyst analyzes blood, registration team registers donor, registration team registers patient, hospital contacts blood bank, and blood bank stores the blood. The next step is to identify the attributes, which we were able to do quite successfully, which are as follows. So here is an ER diagram which clearly shows that the donor donates blood, blood is stored in the blood bank, the manager manages the blood bank, the clinical analyst analyzes the blood, the patient receives the blood, the registration team registers the donor, the registration team registers the patient, and the blood bank contacts the hospital. So this was our ER diagram, and all the attributes of specific entities are mentioned here. The next thing to understand is an EER diagram, which is an extended version of an ER diagram while adding attribute or relationship inheritances, category or union types, specializations and generalizations, subclasses and superclasses. First, let us take an example. Let us say that we have an entity vehicle while we have two more entities called car and scooter. So we can clearly see in this example that vehicle is a generalized entity class or a superclass, and similarly car and scooter are specialized entity classes or subclasses of vehicle. So this phenomena is called generalization and specialization, which is mainly seen in the EER diagram. Let us see the EER diagram that we have drawn for our project. Over here we can clearly see that person is a generalized superclass while donor and patient are specialized subclasses. So this is what we do in our EER diagram, wherein when we move downwards we find specialization occurring, while when we are moving upwards we can simply understand the concept of generalization. I hope you have understood. Thank you and have a nice day.
And this video is on the explanation of schema design and SQL queries of our project Blood Bank Management System. I, along with my classmates Mukul Bisht and Sonalika Arneja, created this project under the guidance of Dr. Shikha Gupta. This project aims to provide a simple solution of managing the blood bank system. So let's straight dive into the schema design of our project. Schema is basically a description of the database, and it is specified during the database design. Schema gives a logical view of the database, and before getting into the schema design, I hope you guys have watched other two videos, that is the video of case study and ER of our project. If not, please feel free to check out the playlist, and I suggest you to watch those videos, as those videos will be important for you to understand the schema design. So getting back to our schema design, these are all the tables in the schema design. This is the blood bank table. Primary key of this table is blood bank ID. Other attributes are as follows: blood bank name, address, state, pin code, contact, manager name, and manager mobile. Other table is donor, whose primary key is donor ID. Other attributes are as follows: D name, blood bank ID, gender, age, contact, blood group, state, pin code, disease, registration team ID, date of registration, last date of donation, amount of blood donated. This is the blood table, whose primary key is blood ID. Other attributes are bank ID, bank name, donor ID, blood group, donor name, analyst ID, donatable, date donated. This is the patient table, whose primary key is patient ID. Other attributes are P name, blood ID, gender, age, contact, blood group, disease, registration team ID, date of registration. This is the donated blood table, whose primary key is blood ID. Other attributes are donor ID, donor name, patient ID, patient name, date of donation. And the other two tables are hospital and disease. Hospital's primary key is hospital ID. Other attributes are H name, that is the hospital name, address, state, pin code, blood bank ID, blood bank name. In the disease table, we have a combination of donor ID and disease as the primary key, because one single donor can have multiple disease, so that hence the combination of these two creates the primary key of this table. And as you guys can see, the lines or arrows, whatever you call it, represents the relation between the table. Like, let's take an example of these two tables, blood bank and donor table. So the donor is related to the blood bank via this blood bank ID. So this blood bank ID will serve as the foreign key. And as you can see the other relations, it is self-explanatory. And as you guys can see the other explanations. So let's move on. So the first query says, find names of all blood banks where blood group O negative is not present. So in the select clause, we have written blood bank name, blood bank ID from blood bank table, of course, where. So here what we have done is that we are selecting that blood bank's name which is not in this relation, and this relation gives away the blood bank's name which contain O negative blood group. Let's move on to the next query. Next query says that find names of all donors whose blood group is B positive located in the pin code 110089, and the donated blood is found donatable but has not been donated to a patient. So in the select clause, donor's name, donor's ID from donor table where blood group is of B positive type, and the pin code is 110089, and the donor is not in this relation. This relation gives away the list of donors whose blood has been donated. As you can see, we have joined two tables, that is the donor table and donated blood table. So this relation will give the donor IDs of those donors whose blood has been donated, and to satisfy our query we have used this not in statement. You guys can pause the video and check the queries by yourself, and if you guys have any doubt you can write it in the comment box. Let's move on to the next query. The third query says list the name of the donors next to their address who belong to the AB positive blood group and are female and do not have any disease. In the select clause, donor ID, donor name, address from donor table, where gender is equal to F as in female and blood group is AB positive and disease is null. So basically, if there is no disease associated with the donor, so in that attribute for that donor, the value that will be stored is null. So basically, this statement says disease is null, as in the donor has no disease. Let's move on to the next query. This is the name of registered donors of age 18 to 28 years from pin code 110045 with diabetes as their disease. Select in the select clause donor ID, donor name, blood group from donor comma disease table where age is greater than 18 and age is less than 28, and from this pin code, and the donor ID is in this relation. So this relation basically gives the list of donor ID that has disease name as diabetes, and that relation is formed on the join of donor and disease on donor ID. D dot donor ID is equal to S dot donor ID. Let's move on to the next query. The last query says list the registered donors who donated blood and who belong to the blood group considered as universal donor, as well as the patient who belong to the blood group considered as universal recipient. So in the select clause, donor ID, donor name, blood group from donor table where blood group is O positive. O positive is considered as universal donor, and it will form a union from patient table, and from the patient table we are selecting patient ID, patient name, blood group where blood group is AB positive. So that's all for this video, guys. If you guys have any doubt, feel free to write it in the comment box, and we'll be happy to resolve your doubt. Thank you so much.
So the next topic is normalization and how it helps in optimizing a database. So what is normalization? It is a database design technique that helps us to reduce redundancy and avoid anomalies in our database. So these are the differences that normalization brings to the table. So we can avoid anomalies or spurious tuples, and moreover it also provides data consistency and other advantages. So these are the few types of normalizations that we're looking at. There are others as well. Here NF represents normal form and BCNF is Boyce-Codd normal form. So in a glance, we could take a look at the definitions of these normal forms, and we would be witnessing the first two in the case study, and for the rest you could take a look at the definitions and get an idea of what it conveys. So this is the schema that we are using for the blood bank management system. So starting off with 1NF, we say that this database is in 1NF because there are no multi-valued or composite attributes in this schema. As say for address, we have not broken down or collaborated a lot of attribute mixtures into it. Other than that, in the donor table you could see that a single donor could have had multiple diseases. So instead of storing those in a single attribute, we have created a different table for diseases where you can store a number of diseases for the same donor. Moving on to 2NF, 2NF says that there should all the non key attribute should be fully functionally dependent on the primary key of the table. So it is evident in this database that all the non-key attributes are fully functionally dependent on the primary key. However, we have a few unique keys in the database as well, but it is in. And now moving on to the 3NF. So you could see here that 3NF talks about transitive dependency. However, we can see that there are a lot of transitive dependencies in this database, and they have not been separated into different tables to allow quicker responses and avoid a few join functions as per the needs of the database. So yes, that's pretty much it for the presentation right now, and thanks a lot for